In the late 1960s, the Soviet space program was deep in the heat of the space race, while the United States focused on sending humans to the moon. The Soviets set their sights on another, more mysterious target, Venus. At the time, almost nothing was known about this planet. Telescopes could see only a constant blanket of bright, reflective clouds. Many scientists speculated that beneath this cover was a lush, Earth-like world. The atmosphere was thought to be similar in pressure to our own, perhaps 1 bar at the surface, and temperatures might not have been far from what we experience on Earth. Some even imagined oceans, swamps, and perhaps primitive life. Against this backdrop of curiosity and speculation, the Soviet Union prepared to attempt something no one had ever done before, to land a spacecraft on another planet. That attempt came in 1967 with Venera 4, the first probe designed to enter the atmosphere of Venus and send back data. It wasn't just about reaching the planet, it was about discovering what truly lay beneath that cloud layer. Venera 4 approached Venus at a blistering 40,000 kilometers per hour. As it plunged into the atmosphere, its parachute deployed, and the probe's antennas began transmitting precious scientific measurements back to Earth. At first, the data seemed to confirm the optimistic theories. The pressure was close to Earth's, and the temperature was around 30 degrees Celsius. But as the descent continued, the numbers began to climb at a terrifying rate. 1 atmosphere became 10. Temperatures soared past 200 degrees Celsius. Soon the readings showed 20 atmospheres of pressure and a scorching environment no Earth-like life could survive. Then, suddenly, the transmissions stopped. The probe had been crushed or overheated before it could reach the surface. The final data revealed a shocking truth. Venus's atmosphere was far denser and hotter than expected. 22 times thicker than Earth's, and over 250 degrees Celsius. The surface was clearly nothing like our home planet. To the outside world, the mission had ended in failure. But to Soviet scientists, Venera 4's destruction was a triumph of discovery. They had pulled back the curtain on Venus's deadly nature. Instead of being discouraged, the revelation only sharpened their determination to try again. This time with spacecraft that could withstand the planet's extreme conditions. Early Venera probes had relatively simple designs, a titanium sphere about 1 meter in diameter, pressurized internally to survive up to 25 atmospheres, packed with instruments to measure the atmosphere's composition and pressure, and powered by batteries for the descent. The probes lacked any thrusters and relied entirely on aerodynamic drag and parachutes to slow their fall. But the dense atmosphere of Venus turned this into a major problem. Rather than falling quickly to the surface, the probes were slowed dramatically. Venera 4, for example, drifted downward at only 18 kilometers per hour, taking over 90 minutes to descend. That meant 90 minutes of exposure to heat and crushing pressure, more than the craft could survive. Soviet engineers realized they needed to spend as little time as possible in the atmosphere. The longer the descent, the greater the chance the probe would fail before reaching the surface. The solution was clear: fall faster, and so the team began work on a radical redesign. That redesign would take shape in Venera 7, launched in 1970, which was built to endure almost unimaginable punishment. Venera 7's key innovation was its parachute system. Rather than fully deploying at the top of the atmosphere, the parachute was rigged with a special cord that would hold it closed until the probe had fallen much closer to the surface. This meant the craft would descend more quickly through the upper atmosphere, reducing its exposure to heat and pressure. The parachute material itself was made to melt at around 200 degrees Celsius, ensuring it wouldn't open prematurely. The spacecraft's protective shell was massively reinforced, twice as thick as before, and able to withstand up to 180 atmospheres of pressure, far beyond what was expected at the surface. The Soviets wanted Venera 7 to survive whatever Venus could throw at it. The descent went mostly to plan. Venera 7 entered the atmosphere, slowed, and deployed its parachute at just the right moment. The quick fall carried it far closer to the surface than any previous mission, but disaster struck when, just 3 kilometers above the ground, the parachute tore apart. The probe plunged uncontrolled, smashing into the rocky surface at roughly 60 kilometers per hour. On Earth, Mission Control marked it down as another failure, until a few weeks later, when a closer look at the data revealed something astonishing. The probe had kept transmitting a faint signal for 23 minutes after impact. The landing had knocked it onto its side, weakening its antenna signal. but the spacecraft had survived. And in those 23 minutes, it confirmed something even more extreme than before. The surface temperature was a hellish 500 degrees Celsius, with temperature now identified as the main barrier to survival. Soviet engineers devised a clever cooling system for the next mission, Venera 8, launched in 1972. Inside the lander, they placed blocks of lithium nitrate, a salt-like substance with a very high heat of fusion. This property meant that when the material melted, it absorbed a huge amount of heat energy without a corresponding increase in temperature. In practical terms, the lithium nitrate acted like a thermal sponge, soaking up excess heat and keeping the electronics cool for longer. The result was a spacecraft that could stay alive on the surface for significantly more time. Venera 8 performed flawlessly, surviving for a full hour on Venus, long enough to take detailed measurements of light levels, which suggested that, despite the thick clouds, the surface was bright enough to photograph. By now, the Soviets had mastered the art of landing on Venus, but one mystery remained. What did this hostile world actually look like? The answer would come with Venera 9, launched in 1975. This probe was a complete redesign. Instead of parachutes for the final descent, it used a large aerodynamic brake to slow down and landing legs to absorb the final impact. Most importantly, Venera 9 carried the first cameras ever sent to the surface of Venus. Designing a camera to work in such an environment was another engineering challenge. The cameras were mounted inside the probe's pressure vessel, with periscopes extending through small, specially designed windows in the hull. The thick quartz windows distorted the view, so corrective lenses were installed inside the periscope tubes. Each of the two cameras could sweep a 180 arc, and together they could create a full panoramic image. Venera 9's landing went well. Mostly of the two lens caps designed to pop off after landing, only one actually worked. As a result, only a half panorama could be taken. Still, it was a milestone, humanity's first photograph from the surface of another planet. The image showed a rocky, uneven plain under a hazy yellow sky, confirming for the first time what Venus's surface truly looked like. Subsequent missions refined and improved on the camera system. Venera 10, 13, and 14 returned higher resolution images, some in color. Venera 13, in particular, sent back stunning panoramic images in 1982, showing a barren landscape of flat, fractured rocks. But the Soviets didn't stop at pictures. For Venera 14, they included a microphone, making it possible to record the sounds of Venus. The resulting audio, the hiss of the atmosphere, and the mechanical thump of an instrument drilling into the surface, offered an eerie, tangible connection to a place 40 million kilometers away. In total, the Soviet Union achieved 8 successful landings on Venus between 1970 and 1985. Each mission added to humanity's knowledge of the planet's crushing pressure, searing heat, acidic clouds, and barren, rocky terrain. No other nation has since matched that record. Even today, over 50 years after Venera 7's hard landing, no spacecraft from Earth has repeated the feat of surviving for long on Venus's surface. The Venera program stands as one of the great triumphs of robotic space exploration. What began with the loss of Venera 4 in the crushing atmosphere became a steady march toward mastery of one of the most extreme environments in the solar system. The Soviets learned to adapt to fall faster, to protect against unimaginable heat, to shield delicate instruments against pressures that would crush a submarine. And in the process, they gave the world its first direct look, and even its first sounds, from the surface of our most dangerous neighbor. Venus remains a place of fascination, a world that challenges our engineering, our expectations, and our imagination. The story of the Venera probes is a reminder that exploration is rarely easy, and that even in the face of repeated setbacks, determination can bring extraordinary rewards. Today, as new missions to Venus are being planned by multiple space agencies, the lessons learned from Venera will guide a new generation of explorers into that hostile, beautiful world. And perhaps, one day soon, we'll hear again the faint whisper of a spacecraft calling home from the surface of Earth's deadly twin.